we're looking at this scenario. Powers of tangent or cotangent. So if we just have tangent in the integral or cotangent raised to an exponent, we're going to factor out a tangent squared or a cotangent squared and rewrite it as one of these, using one of these Pythagorean identities. Sometimes you're going to have to do this more than once. And that's the case with number 5. So let's look at number 5. We're going to take out a tangent squared, so we're going to rewrite this as tangent cubed of x times tangent squared of x dx. And we're going to take this tangent squared and rewrite it using that Pythagorean identity. Secant squared of x minus 1. So we have antiderivative of tangent cubed times secant squared of x minus 1 dx. From here, we're going to go ahead and distribute this. We get tangent cubed of x times secant squared of x minus tangent cubed of x. Well, we've got two parts now. We've got this first part, second part. This first part, we can actually find the antiderivative of this using u substitution, because what's the derivative of tangent? Secant squared, right? So if we made tangent our u, we'd get u cubed times, this would be part of our du, right? So we'd be able to do that. But in this part, tangent cubed, that's kind of the same scenario we started off with. We have tangent raised to a power. So what I'm going to do is I'm going to split these up into two separate integrals. This first one, we can use u substitution. Second one, we have to use the same process that we just started off with. So let's go ahead and do our u substitution before we go on to the next line. U is going to be tangent of x. Du is going to be secant squared of x dx. So we end up with u cubed du for our first part. Second part, we're taking out a tangent squared, so we're going to write it as tangent of x times tangent squared of x dx. Well, first one, we can do the antiderivative of that. We get 1/4 u to the 4th. We'll save the plus c until the end. Once we're done with this integral. For this one, remember we changed the tangent squared into secant squared minus 1. We're going to do the same thing here. Tangent of x times secant squared of x minus 1. We can distribute that tangent to each of those. For this part, I'm going to go ahead and replace the u with tangent, so we get 1/4 tangent to the 4th of x, minus, we get tangent of x times secant squared of x, minus tangent of x. So again, we've split this up into two parts. This first one, we can use u substitution again. Tangent is u, du is secant squared. So I'm going to split these into two integrals. And then antiderivative of tangent of x, that's one we know, we just talked about on the other side of the sheet. So we can do that without any substitution. But this one, u is tangent, du is secant squared. So we have 1/4 tangent to the 4th, minus the antiderivative of u du, minus antiderivative of tangent, what's that? Natural log of absolute value of secant of x plus c. So just one last part here, and then we are done. 1/4 tangent to the 4th of x minus 1/2 u squared, so we can write that as 1/2 tangent squared of x minus natural log of absolute value of secant of x plus c.